So we're coming back to functions and basic curves. And remember I said you could create any quadratic by translating or rotating and things like that with the basic one. So all right, we want to look at how that happens, the translating curves. So the first idea is we could have a horizontal shift. And that's when we replace x with x minus h. Okay? So y equals function x minus h. So the original curve would be function x. Our new curve is function x minus h. So what does that do? It's going to move the function horizontally h units, either to the left or the right. Now, if you ever get confused which way it goes, the simplest thing to do is have a look at x minus h and say, well, what would make that equal to 0? Solve that, and then you know where the origin's been moved to. A vertical one, same sort of idea, but now we replace the y with y minus k. You might not have thought of it that way before, because normally we just see it another way. So what I'm saying is, instead of y equals function x, I'm saying we've got y minus k as function x, but what you normally see is that, y equals function x plus k. But in reality, what you've done, same idea as with the horizontal shift. With the vertical shift, it's the y minus k. Okay? Again, how have I shifted? Make y minus k equal to 0, and then you get the answer. Although it's a bit more obvious when it is y equals function x plus k. You know, okay, we've moved it up or moved it down. Well, let's look at an example of that. There's our basic parabola, right? It's a quadratic. So the thought process when I see something like this, I go, okay, I've got y equals x squared. That's my basic curve. What have I done to it? Well, hang on. The x minus 3, that tells me I'm going to shift it right 3 units. It's a horizontal shift. It's grouped with the x. If I'm unsure, I go, oh, well, hang on, x minus 3, what makes that equal to 0? Oh, 3 would. So I've shifted it across 3. Okay. But also, I'm shifting it up 4. And there's our new parabola. Okay, y equals x minus 3 all squared plus 4. So that's the basic idea of translation. Move it horizontally, move it vertically. This one here, it's a circle. I know that because I notice the power of y and the power of x is 2. So it's both 2. And the coefficients are the same. So it must be a circle. But until I complete the square, I can't really tell the shift. So I'm going to complete the square. When I do all that, because I've got to complete the square on both the x and the y, I end up with x plus 1 squared plus y minus 2 squared is equal to 9. So now I can read it off at what's happening. So we've got our basic circle, x squared plus y squared in this case is equal to 3 squared, so the radius is 3. But then if I look at the x one, it's grouped with the x, I must have shifted it left 1 unit. So I'll just move that across 1. But then it's grouped with the y, so y minus 2, so I must have shifted it up 2 units. And there's our circle. So the centre's minus 1, 2. I probably should have labelled the radius in there, but that was bad of me. The radius is 3. Y equals 2x squared plus 8x plus 5. Now, okay, we could go through our whole curve sketching menu of going, oh, well, it's concave up, let's find the axis of symmetry and so on. But if we think of it this way, I'm going to complete the square. Now, when I complete the square, I like the x squared to be 1x squared, not 2x squared. So I've divided everything by 2 there. Okay? Always easier to do x squared than 2x squared. Now I can complete the square. So x squared plus 4x would be x plus 2 all squared, half the coefficient of x. But that would create 4, so I need to subtract 4 to balance it out. So I end up with x plus 2 all squared minus 3 on 2. Now I'll multiply the 2 back in, and I get my equation. The shift then, so it's basic parabola. The curve gets steeper, because it's got a coefficient of 2 there. So the curve gets steeper. Remember that idea we talked about before? So, whoop, there we go. I just made it a bit steeper. Shifted it left 2 units. So, here we go. And shifted it down 3 units. Down it goes. And there's my parabola. There's my parabola. So a little bit more work involved with that one, but still the same idea. We just work out how far left, how far up. Now, reflecting curves then comes with changing the sign. So if I want to flip vertically, vertical reflection, so that's a horizontal flip. So we replace x with minus x. So it becomes function minus x. That would be a reflection in the y-axis. In the y-axis. Now, if you want to reflect in a different vertical line, then you replace it with 2a minus x. That will get a reflection in a. Let me show you. There's y equals function x. If I flip it, that's function negative x. That's just a flip in the y-axis. Over there is function 2a minus x. Okay. And you can see, if I draw in x equals a, see how it reflects in that line x equals a. So function 2a minus x, how did I know that? Because once I had function x, I've moved it horizontally 2a units. So the origin went to 2a. But visually I can see, oh, that's a reflection in x equals a. So it does two things in once, the 2a minus x. But say if you're doing the two things, if you see it, you go, oh, 2a minus x, I know that's just a reflection in x equals a. Bang, you can do it straight away. Same sort of thing happens horizontally, but now we replace the y with minus y. So minus y is function x. Mind you, we more normally see it as y equals negative function x. That'll reflect in the x-axis. But again, same sort of thing happens. If I want to reflect in the horizontal line y equals a, then I'll replace it with 2a minus y. And playing around with that, we'd end up with y equals 2a minus function x. Again, let's just show you how that happens. Y equals function x. So that would become y equals minus function x. So y equals 2a minus function x. I would move it up 2a units. And if you look at that very closely, yes, that is a reflection of the original graph in y equals a. So again, it does two things in the one step. We got 2a minus function x. The other thing you could do is reflect in the origin. Now the origin is a point, not a line. So when you reflect in a point, you get rotational symmetry. So it rotates it 180 degrees. So if you see y equals minus function minus x, so both of them are negative. So you end up with a rotation of 180 degrees because it's both of those reflections. Essentially what you're doing is, first of all, you're reflecting in the x-axis, then you're reflecting in the y-axis. Let me show you. There's y equals function x, some random curve that I've got there. If I was to reflect that horizontally, we get y equals minus function x. Now if I was to reflect it vertically, I get minus function minus x. And can you see how the original one has been rotated 180 degrees? So minus function minus x, 180 degree rotation. So what would this look like? Minus x plus 1 cubed plus 2. Well, we know it's our basic cube, albeit a rather dodgy looking cubic. What have we done to it? Well, the first thing I'm going to say, I've got a reflection in the x-axis. Because you see the negative is grouped with the x. See? So I reflect. Then we've got some shifting happening. We're going to shift left 1 unit. And we're going to shift up 2 units. And there's the position of our new curve. Let's have a look at this exponential one. Let's see how it's got both negatives happening here. This one's minus 2 to the minus x. So there's the basic curve, 2 to the power of x. This one we're going to reflect in the origin, or rotate 180 degrees. It would end up down there. Let's add that to our list.